In this video, I will show you how to use Excel to help us choose the right projects to invest under 4 different scenarios. So the first scenario, we are choosing projects based on their net present value. So all we need to do is to calculate the net present value. We use present value minus development cost minus commercialization cost. You can just drag them down. As long as the net present value has a positive number, we will just go ahead to do the projects since we don't have any limitation on the budget. So as long as the net present value is positive, we can say, okay, let's go with the projects. And if it's smaller or equal to 0, we just kill the project. And there's a ranking column. We will not use that here, but we will use the ranking for the next scenario. But I will just show you here how to rank the projects based on their net present value. So we just use the function called rank.average, and then we will choose the number we want to rank, comma, and choose the reference, the array. I will lock all this array because I will need to drag that down, and then comma, I want to rank that from the largest number to the smallest, so I'm using a descending order. All we need to do is just drag them down. There you go. We'll just select all these projects that says go here. In the second scenario, we are choosing the projects based on the net present value productivity index. So we will use the net present value divided by the development cost. And I think I made a mistake on the original template by putting development budget here. Actually, I'm trying to include the both development cost and commercialization cost, and the budget is for both. So we have to copy over all the commercialization cost, and we need to calculate the total cost for each project first. And then if we don't have any budget limit, we can definitely do the same thing. We can go with all the projects that has a positive network present value productivity index. But since we have a budget of 25 million, we have to choose among all these projects to produce the maximum profit. So in order to do that, we typically choose, we begin with the project that can generate the highest productivity index, and then we just accumulate the cost until we reach the budget limit. So let's just rank them first based on their productivity index. So as you can see here, we will start with the one with the highest rank. Okay, this is this project, and at the same time we are calculating the total sum of cost to make sure that we don't exceed the 25 million. So we'll start with the first, the top project, then we can add the second one and the third one, and as you can see, the sum of cost right now is 19 million. We're still fine with that. Then we can continue with the fourth one. Now we reached at 20.25 million budget. Let's see if we can go with one more, number 5. If we choose number 5, then we will exceed the budget, so we cannot choose number 5. So the conclusion is that we can choose project that ranks from 1 to 4. Okay, and we just kill all the other projects. But that's basically how you choose the projects based on their productivity index. You rank them and you add up all the costs to make sure it doesn't exceed the budget. And let's see, let's calculate what's the total profit we made by selecting those projects. So we have this project, we have this, we have this, and we have this. As you can see, the total profit we made is 63.75. So let's put it aside, 63.75. Okay. However, is this the actually maximum profit we can make? We don't know yet, but we can see we didn't use all the budget. We just used 20.25 cost, and this is the profit we can make. So in order to find out if we maximize the profit, in Excel there's another function called solver that we can use to help make us decision like this. So let's add another column called solver decision. If it is a go, I will enter 1. If it's a kill, I will enter 0. It doesn't matter what's the number here right now. I just want to show you that we can calculate the total profit using a function called sum product. The profit is net present value divided by sum product, the solver division, and the cost. We also use sum product, and we choose cost and this arrow. So it will tell us what's the cost and the profit when we choose or not choose any projects. So in order to use solver, you have to go to File, Options, and Add-ins. And then you choose Excel Add-ins, click on Go, and make sure that you check the solver add-in. And after you did that, under the Data tab, you can see there's a function, that group called Analyze, and there's a function called Solver. We can just click on that, And our objective is try to maximize our profit. So I will select this cell and then choose max. And how do we change this profit is by changing the number here. By changing the number here, whether we will select the project or not. And then we have certain constraints. So we can add constraint. The first one I need to choose is a deletion. That is a binary number, whether it's 1 or 0, whether it's go or kill the project. I can just click add, and I will add another restraint, which is the total cost cannot exceed 25 million. So it's smaller or equal to 25 million, and click OK. So these are basically the only two constraints we have, and then we just click on solve. OK. And now you can see by using solver, it gives us a different selection. So we choose this project, and we choose this project, and we choose these two. And you can compare the result by using the ranking and using the solver. By using the solver, we're actually using more budget, but at the same time we're producing much more profit as well. So I will go with the solver deletion. Okay. So if that's 1, I will say go with the project, and if it's not, I will just kill the project. Okay. So this is our new deletion. Okay. And then we can do the same thing for scenario 3 and scenario 4. The only difference between these two is the total budget. We will have less budget for scenario 4. So let's just calculate some of the numbers here. So expected value before launch. For the ECV method, we start from the right side and we go back first. So we start with the present value and we calculate the expected value after launch. So it would be present value times the probability of commercial success plus the present value times plus the value if commercial fail times the probability of commercial failure. We don't have the direct number, but we can use 1 minus the probability of success in order to get that. If you want to get the answer faster, then you can just ignore the last part, because all the values if failure is all 0, so you can just omit the second part. Okay, let's just drag that out, and then expect value before commercialization, we just minus the commercialization cost here. Drag that down. then expected value in development. Okay, this value. So we will use this number times the probability of technical success, and you can plus the value if failed. Since it's zero, we just keep that. And then drag that up. Then expected commercial value. This one. So we will use this minus the development cost. This is the number we're looking at. Then we can use the ECV divided by the development cost to calculate the productivity index. Okay. Sum of cost, it's the sum of development cost and commercialization cost. Okay. And again, you can rank it based on the expected commercial value. And then you can again use the solver to help us. In order to use the solver, the objective you select must be a formula. So we are looking at we're comparing the cost, let's say profit or ECV, and cost. Okay. So the cost will be a sum product of the total cost and this division. This would be a sum of cost. Then for the total of ECV, it's also sum product ECV, and then this. Okay. The next thing is we can just use data solver. This time we're going to maximize the ECV, okay, by changing the division here, and the constraints this time would be this must be a binary, and then the cost must be smaller than 25 million. Then click solve. Okay, and here it is. So if this is 1, then I will go with the project. If not, I will kill the project. Okay. And then we can see we will go with this one, these 2. So we'll go with these 4 projects, okay. And we are actually used up all the 25 million budget, and we have a total number of ECV of 10.9. Okay. And for the last scenario, we are actually doing exactly the same thing. Let's just copy over some of the functions here. Then this minus the commercialization cost. this times the probability of technical success. Then we subtract the development cost. Then we use this divided by the development cost. The other difference between scenario 3 and scenario 4 is that with less budget, the probability of commercial success and technical success has been changed. So we will have, that's the reason we will have a different number here. Okay, sum of cost would be development plus commercialization. And you can do a rank here. Sorry, we are actually ranking them based on the ECB. And in order to make a division, let's insert a solver column. Everything looks good, so we can use data solver again. This time our objective is to maximize the ECB here by changing these cells. This time our constraints are again, or the division must be either 1 or 0, and then the total cost cannot be more than 17. Okay. Then solve. Okay, and let's use an if function again. If this is 1, I will go with the project. If not, I will kill it. So as you can see here, with less budget, we can only choose these 3 projects. We used up 12.3 million cost, and that's it. That's the maximum ECB we can generate with 17 million budget. I hope this video will help you know how to use solver to solve and select the projects. And please let me know if you have any questions, or if you are not familiar with some of the functions we demonstrated here. Just send me an email. Thanks.